Good morning, one and all. My name is Dr. P. Sinaslo, Department of Mechanical Engineering. Today we are going to discuss about the manufacturing process of a types of a flames. Okay, let's we discuss the types of a flames. Means here, what is going on? Means there are three types of a flames are there. Means of a neutral flame, carbonizing flame, and oxidizing flame. And after that we are going to discuss about the shield metal arc welding and submerged arc welding here. Now the types of flames here. So from the diagram, the types of flames are neutral flame, carbonizing flame, and oxidizing flame here. So if I am speaking about the neutralizing flame, so from the diagram, yeah, torch tip is there. Another one is the inner white cone, outer envelope, and the outer bluish flame here. So here, what is going on? Means there is a mixture of uh, oxygen and acetylene is taken place here. Oxygen and the gas here. Okay. In a neutral flame, we are also saying there is a no chemical reaction is taken place here in a neutral flame. No chemical reaction is taken place in a neutral flame. So here what happened, there will be a ratio between of a oxygen accelerator is a, we are saying that is a ratio, it may be 1 is to 1. Okay. And the mainly of a, we have seen from the diagram is a inner white, it is a forms of a two flame, means here two cones are there. Is a one is a white cone, another one is a outer bluish flame here. So the inner white cone of a here is a temperature which is maintained of a 3100 degrees Celsius, and from the outer flame, which is inner is a white inner cone and the outer is a bluish in color. Okay, so it is a maintain of a temperature of a 1275 degrees Celsius here. Means here the gas and the oxygen's ratio, means gas and the acetylene ratio, or we can say is a 1 is to 1, we are maintaining that one, that is a neutral flame, and there is no chemical reaction is also taken place here. And especially this is mainly useful for mild steel or stainless steels, or we can say that is a cast iron. These are the things which we are using of a neutral flame. Now coming to the carbonizing flame. So when I am saying of a carbonizing, the term of a carbonizing means here the mixture of acetylene and the oxygen is taken place here. Means here the acetylene is a more compared to the oxygen. Means the ratio of a acetylene of a or gas is more compared to the oxygen flame. Oxygen here. So here the chemical reaction is also take place here. Okay, that is a carbonizing flame. Mean here what happened, which the metal takes a carbon absorption, means the reaction when the welding can be taken place here, there will be having a carbonizing, means which can absorb the carbon. That is a carbonizing flame here. So here the inner whiter cone, which is maintaining of a temperature, is a 2100 degrees, 2900 degrees here, sorry, 2900 degrees. And from the outer bluish of a flame, we are maintaining of a C here, which is a, we can also say that is a maintaining of a 2100 degrees Celsius. We are maintaining here 2100 degree, we are maintaining in a intermediate flame feather. We can also say that is a acetylene feather also, we can say acetylene feather also, we can say that one. So here the carbon acetylene of a or gases is a more ratio compared to the oxygen here. Now we can where it is can be useful, means here which is a medium carbon steel, means here of a carbonizing of a observation can be taken place here, that is a medium carbon steel. Also we can go with the nickel also, we can go ahead in the same manner. Now the third one is oxidizing. Here the oxidizing means here the oxygen is a more compared to the acetylene here. So here we are saying the oxygen is a more, we are taking off oxygen is a more compared to the gas, or we can say that is a estate. So here the inner cone, the wider inner cone is a, we are maintaining of a 3300 degrees, and the whereas the outer is a very more than that one. Okay. Now coming to the here where it is useful here, means copper alloy we can use there, and the brass, or we can also go with the bronze also. There are the different types of a flame, means what is a neutral flame, carbonizing flame, and oxidizing flame. Neutral flame where or acetylene and the oxygen means what happened here, the gas or acetylene and the oxygen levels are same here. We are taking of a same level, means ratio is the same, 1:1 here. Even for the carbonizing flame here, what happened, the gas or acetylene and the oxygen means here the acetylene level is a more compared to the oxygen level here. In oxidizing flame here, the oxygen level is more compared to the acetylene level here. So these are the types of a flames here. Now coming to the here our advantages where it can be taken place here. Portable and the more versatile process can be taken place here because this is take place in a gas welding process here. So it is a portable and more versatile process, better control over the temperature because we know that what is the temperature can be taken place here, and very and suitable for welding of a dissimilar metal means here the dissimilar metal can be welded very suitable, it is useful for and a low cost of the maintenance oxyacetylene, that is the reason. And but is a not suitable for disadvantage is not suitable for heavy section and less working temperature of a gas flame due to the, you know that gas flame having a very less working temperature means we require of a more temperature for the welding purpose. But what happened here, we are using of a 3300 more than that one, the maximum we are using, and the slow rate of a heating also. These are the disadvantages. Now coming to the shielding metal arc welding. The shielding metal arc welding is also called as another name is that manual metal arc welding, or we can also say that one. So here what is going on here? This see from the diagram. So there is a base metal is there, and if I am going for the uh, base metal is there, weld metal is there. So well, what happen here when a welding is taken place here means there is everything is see here from the diagram. The bay this is from the here how the DC or AC can be connected to the due to with the help of electrode of a cable, electrode holder. So there will be a connection is taken place here. Means electrode holder is holding of electrode, and the arc is produces of a nothing but in a between of a workpiece here. Okay. So here what is going on here is that there is a two terminals. Is a AC means for machine it is a connected to the electrode cable. Another one is a work table. Means that is a comes in a our polarity, state polarity or reverse polarity. It can we can also say. So here after that we will go with the shield metal arc welding. Before going to that one, let's we discuss about the what is the state polarity and the reverse polarity. Okay. So what is from the welding of a machine is here is a we are going means one connection we are giving to the electrode holder, another connection we are giving to the work table here. Okay, means here what happened when given of a AC or DC. So what happened, it will through the electrode holder which is connected with the electrode. So here with a burn of a electrical to what happened here, the electrode gets melts here and it will form a arc, it will form a joint at the welding zone here. In the same manner, see here, there is a polarity of arc welding, if I says. So what are the means here? State polarity and the reverse polarity. Means of a DC of a power supply is there. I am giving a positive terminal to the workpiece and negative terminal to the electrode, which is connected to the electrode of a holder to the electrode here. We are saying that is a state polarity. Means due to that, what happened here? Higher burn of rate of a less penetration will be taken place. In the same manner of a reverse polarity means the negative terminal I am giving a connection to the workpiece and the positive terminal I am giving to the electrode here. Means here deep penetration with a low burn of rate can be taken place. This is a vice versa can be taken place here. Okay. Means the main here is a difference is a we are giving a positive terminal to the workpiece here and negative terminal to the electrode here. If a vice versa is state polarity, it becomes of a reverse polarity here. Now coming to the here ours is a types of a arc welding. It will be a shield metal arc welding. We are discussing after the slides. Okay, and what is a means types of arc welding? It is shielded metal arc welding of a metal arc gas welding, metal inert gas welding, electro gas arc welding. Here there are different types of a arc welding here. Now we discuss about the just now I said shielded metal arc welding is also known as manual metal arc welding. Okay, and here the flux which is a shielded means what is the use of a flux shielded here? means which is protect from the atmosphere, means whatever the contamination is taken place at the welding zone here, due to this flux it will make there is no contamination, or it will prevent from the atmosphere to the at the welding zone here, at the welding zone here it is protect from that one. That is the use of the flux shielded arc welding, or we can say that is a informally of a as a stick welding also we can say. It's a manual arc welding process that uses of a consumer electrode here and cover with a flux or to layer the weld here. Means due to the flux of a which is a shield, means the flux is coated on the electrodes here. The flux which is coated on the electrode here. So whatever it is welded has a means of a melted as well as in the meanwhile whatever it is protect from the atmosphere. Flux is a mainly is a support of a, see this is act as of a flux. Just imagine this is a nib is a of a electrode here. Is a up one is a act as a electrode means of a flux here. So what happened? It is protect from the atmosphere, not to contaminate with the welding zone here. And the welding techniques that can be used to means especially for the all ferrous of a material in welding position, means especially this type of a thing can be taken place at the angle, not with the perpendicular welding can be taken place here. If it will perpendicular, what happen, this electrode gets off a stick with the workpiece here. So it's avoiding that one, we are going for some angle so that it will not stick with that metals here. See, this is some angles. See the 90% of weldings are take place of some angle only, not with the perpendicular to the metal. So due to that one, what happened here? The electrode and the molten of a here is a base metal. So what is the going on when I'm going for the, see here, when I'm this is from the diagram, okay, this is the position, okay. So what happened, I'm moving from here, I'm moving from the left to right. What happened here? So there will be having a uh, uh, when I am moving off a electrode which is a near to the workpiece here. So what happened, there is a, first it will melt off a some portion of the base metal, then there will be arc will be a producers, see from the diagram, okay, there will be arc will be a producers here, and the weld deposition can be taken place here. About that one there will be a slag here. So there will be a flux which is nothing but a, it is a projection of a sheath we can say, and the gases of a shield we can also say. And due to this one, shielded or a heavy coating can be taken place, electrode core of a wire can be inside that one. In this way what happened, when this is moving forward here, so here it will get a first of a melt of a base metal here. This metal of a base metal means this is melts of a base metal here. Then what happened, and in the meanwhile what happened here, there will be a melting can be taken place here, and there will be arc will be produced at the welding zone here. So after that there is a slag will be produced, so there will be a welding zone is produced on that one. See, there is a simple concept is a one of the arc welding process that is a commonly used, means we know that one is arc welding. Example, our in our house we are using of a welding of our gate or welding of our grills. So this all type of a construction or a process or a fabrications, so this type of a construction and fabrication is a very well known of that one of a, by using of a arc welding. We can also say that is a metal arc welding also, means here the we have seen that one the where electrode is a filled with, means electrode is a means coated with a flux, that is a mainly we are known that one, okay, or informally known as a stick welding also. And the electrode used in this process is a consumable, and a rod is covered with a rod, we know that one, this rod is a covered with a flux, some flux, okay. And here due to this of a flux burns to form a protective layer and cover for the weld. You have a very well known, we are using of a some protective of a from our eyes also is a gloves on that one, okay, from some shield, so that it is a protection because we can't see that one directly. So there will be a due to of a some heavy of a spark and the spatter. So what happened, we are using a some shield. So we have seen that one, we have whenever you move from our area also we have seen that whenever welding is taken place, so that is the 90% of our fabrication of our householding and industries also we are using of a arc welding process. This process is very well known of this one. And the flux burns to form a protective layer and cover for the weld layer. The current type used in this process can either be AC, we can use of AC, or we can use of a DC depending upon the design of the weld and which will be stated with we can say that the WPS is nothing but a welding procedure of a specification we can say all the time. So that is a depend upon the welding of a process. We can use of AC current or DC current, and here what happened, just of a here the electrode which is coated with the flux. We are just moving of a at the welding of the first it will be nothing but it will of a somewhat it will be a molten that of a means of a workpiece here. After that it will gets of a melt here of and it will make a joint here, and joint after that it will forms of a some arc on that one. Okay, after chipping we can use of a beads we can also say. Okay, now the working principle, if I say of a, the current flows in through the cable, just now I said of a cables, electrode of a cables is connected with the cables here. So here the ground cable and the hot cable from the power source of AC or DC, which is a circuit, is a completed when the electrode is a tip is comes and a contact. Electrode tip. This is a imagine this is a tip is there. Okay. Electrode tip is a come in a contact with the surface of the workpiece as will be seen already. We have seen enough a letter of means of previous of a diagram here, and the heat is a simply of a generated a meeting point here, and between the electrode and the workpiece here are, and heat input can be however we are having some formula that and what is the distance will be there, at what temperature it will be gets of a melt here, and the shielded of a metal arc welding is a transform, means here what happened, how it can be means how it can be welding of a means of a welding of a machine, just now I said of a AC or DC of a machine or in, so here that is a, we are every time we have seen of a welding person, whenever he comes he will come with some machine that is the connected with the AC or DC depend upon the situation here. Okay, and upon the fundamental fact and one side of the welding circuit which is attached to the work steel, we know that one of a circuit, one of a terminal we are connecting with the electrode, another terminal we are connected with the this one work table here. So according to that one, a welding electrode is connected to the other side and the two brought into a contact and arc will be established. When there will be a contact, means there will be a, when an electrode is a contact with the at a welding of a zone, a welding of a pieces here. So what happen is two workpiece here, if I'm making of a contact between this, so what happens, there will be a welding will be formed here. So if the arc is properly controlled and a metal from the electrode will pass through the arc, will be a deposit, just now I said of a arc will be a deposit on the steel or it may be a MS, that is a depend upon the ferrous of a materials. When an electrode is moved along the steel at the correct speed, the metal will deposit in the uniform there and called as a bead, just now I said. When I am saying of a here the electrodes, it gets of a melted here, it will move up to here. Electrode, which is connected with the electrode of a holder here. So what happens when it gets of a melted here, it forms of a some layer. Arc will be formed. Means we are saying that is the sense of that is the means of beads here. And the flux coating of an electrode, why we are using of a flux, just now I said it is there, so there will be having a, when a flux is there, when a flux coated is there, what happened here, just now from the diagram it will be slag will be formed. What is that means of a shielded of a layer is a flux which is nothing but protected from that atmospheric, that is a weld put from the atmosphere contamination, that is solidified. Means I said of it before also, the flux is mainly depends upon how means it is a protect from the atmosphere, because there is a, so many contamination is taken place, it will prevent from the atmosphere, so that is a solidifies here. Okay, and the slags are a later of a chip, means the slags which is formed of a after means of above of a weld pool, what happened here, there will be a slag, so we are removing by using of a chipping hammer we can say. So the penetration depth of a weld could either be a full penetration or partially. When I am saying of a full welded means welded can be taken. When I am saying of a incomplete penetration means what happens, there will be a uh, there will be having a some cracks or porosity or holes, means it comes in a defects of a in a welding zones we can say. So here if I speak about defects association with a shielded metal arc welding are some as patterns we can say, porosity we can say, incomplete penetration, cracks, undercuts,